All right, so we're going to do lesson 27.1, where we are going to factor trinomials of the form x squared plus bx plus c, where, and this is particular because our a is always going to be 1, so the coefficient to x squared is 1. So our learning targets for today, we're going to be able to use algebra tiles to factor trinomials of the form x squared plus bx plus c. And then we're going to be able to then take that information and then just factor trinomials of the form x squared plus bx plus c. We're not going to do the whole lesson. I'm actually going to skip down to page 395. So what we're doing with factoring these trinomials, we are trying to find the two binomials that multiply together in order to get those, to get that trinomial. Now, there's a couple things that we need to know. The first term of our trinomial, x squared, is always the result of our first terms of each binomial being multiplied together. And the last term of our trinomial, so our c, is the result of the two last terms in my binomial being multiplied together. What we need to figure out, what are the two linear terms, so the bx, that get added together to form our bx. So one way we can do this is we can use a kind of like our box method, just in reverse. So we know that my first term of my trinomial is the result of x times x, so x squared. So we know that for our binomial, we're going to have x and x. And then we know that the last term of our trinomial is the result of our two last terms of our binomial being multiplied together. So what we're going to need to do is we're going to need to identify the factors of c, so of 32, that add together to be b, which for this example, it's going to be 12. So we're going to list off the factors that multiply together to be c, and then we're going to see what those factors' sums are in order to see if they would add together to be b. So just listing off the factors of 32, well, we have 32 times 1, so that would give me the 32. But would it add up together to give me the 12? Well, 32 plus 1 is 33, so that one didn't work. We could also think of the factors of 16 and 2. Well, they multiply together to be 32, but when we add them together, they get to be 18. Then, so we have to think of a different pair of factors. So what about 8 and 4? Well, those multiply together to be 32, and they add up together to be 12. So that means the two last terms of my binomials are 8 and 4. And we can prove that by filling in the missing factors and then in products and writing our answer as the sum. So we have x plus 8 and x plus 4, so that would give me x squared plus 8x plus 4x plus 32, which would then give me x squared plus 12x plus 32. So my two binomials are x plus 4 times x plus 8. And what's nice about when we're factoring is we can re-multiply these together to make sure we're correct. And so I'll just do that real quick. So we have x times x, which is x squared, 4 times x, which is 4x, x times 8, which is 8x, and then 4 times 8, which is 32. And combining like terms, we get x squared plus 12x plus 32. So we know that we're correct. So the two numbers that multiply together to be c, but add together to be b, become the last terms in each binomial. So I'm going to skip down to, the try these. So it says fill in the missing sections of the graphic organizer for the trinomial x squared minus 6x plus 8. So we know that to get x squared, I'm going to let it readjust itself. To get x squared, it would be x times x. It gives me that we have negative 4x. Well, x times what is negative 4x? Well, that would be negative 4. Negative 4 times what would give me 8? Well, that would be negative 2. So my two binomials would be x minus 2 times x minus 4. And again, we can prove it. We have x squared minus 2x minus 4x plus 8. So x squared minus 6x plus 8. We're going to get past making this graphic organizer. What you need to do is what you really need to do is you're just, okay, if Cami would just calm down a little bit. You're just looking for two numbers that multiply together to be C, add together to be B. Those are your last two terms of your binomials, because your first two terms will always be x and x. So they need to multiply together to be 45, add together to be 14. So just thinking of factors of 45, I have 15 times 3, but those add together to be 18, so that doesn't work. We have 9 times 5. 9 times 5 does, in fact, add up to 14. So 9 and 5 are my two factors, or my two last terms of my binomial. So this would be x plus 9 times x plus 5. And again, we can check it. Get x squared plus 9x plus 5x plus 45. So we get x squared plus 14x plus 45. Okay, let's do the same thing with C. So we're needing two numbers that multiply together to be negative 27, that add together to be 6. So just thinking of factors of negative 27, we have negative 9 times 3. When I add those together, I get negative 6, so that doesn't work. So what if I switch to the negatives? So 9 times negative 3. That multiplies together to be negative 27, and it adds together to be 6. So those are my two last terms of my binomials. So we have x plus 9, and then x plus, not plus 3, minus 3. All right, let's do D. So again, we're looking for two numbers that multiply together to be 1, add together to be 10. Well, I'm just thinking of factors of 1. It's 1 times 1. That adds together to be 2. There are no other factors of 1. So since I don't have a number that multiplies together to be C but adds together to be B, this is unfactorable, or it's also called a prime polynomial. So this is a prime polynomial. We cannot factor it in this way. Let me know if you have any questions.